So this video is a quiz for those of you who need to review basic atomic structure, the structure within an atom. So let's start with this question. Which of the following particles is found outside of the nucleus? Is it the electrons, the neutrons, the protons, or is it a combination of two of the three answer choices listed here? Well, let's talk about the structure of the atom. In the center of the atom, which is known as the nucleus, you have the protons, which I'm going to write in red, and the neutrons, which I'm going to put in brown. Outside of the nucleus are the electrons. The electrons are orbiting the nucleus. And so the electrons form the electron cloud. But the nucleus consists of the protons and the neutrons. Now, the atom is mostly empty space. Even though this picture doesn't show it to scale, this nucleus is relatively small to the electron cloud. And so a lot of matter, like high energy particles, can go straight through an atom because an atom is mostly empty space. 99% of the mass is concentrated in the nucleus of the atom. Protons and neutrons are almost more than 1,800 times more massive than an electron. So going back to this question, the particles that are found outside of the nucleus are the electrons. A is the right answer to this problem. Now let's move on to this problem. Number 2. Which of the following subatomic particles carries a positive charge? Is it the electrons, the neutrons, or the protons? Neutrons are electrically neutral. They don't have a charge. Think of N for neutral. Protons carry a positive charge. Think of P for positive. And electrons carry a negative charge, but you have to just know that by elimination. So the answer for this one are the protons. They carry the positive charge. So C is the right answer. Now going back to the structure of the atom, I have some questions for you. So we said that at the center we have the protons, which carry a positive charge, and the neutrons, which carry a neutral charge, or no charge at all, and the electrons, which orbit it, and they carry a negative charge. Now perhaps you've taken physics and you know that opposite charges attract. So if you have a positive charge and a negative charge, there is an electrostatic force of attraction that accelerates them toward each other. So therefore the electrons are attracted to the nucleus. So why don't the electrons just fall into the nucleus? What keeps them in orbit around the nucleus? It turns out that their speed keeps them in orbit. They're moving pretty fast. Whenever you have an object that's moving in one direction, and if there's a force that's perpendicular to the motion of the object, the force doesn't change the speed of the object, rather, it changes the direction of the object. So the electron at this point wants to fly outside of the atom, but the electrostatic force between the electrons and protons help keep it in orbit. So the electron doesn't fly out of the atom or doesn't really fall into the nucleus, as long as it maintains the right energy. Now, if an electron absorbs a photon and gets a lot of energy, sometimes its kinetic energy might be high enough where it can fly off and leave an atom, if it has the right energy. And there are times where an electron actually can fall in the nucleus, and a nuclear reaction can occur. But that's a whole nother topic. But for the most part, electrons tend to stay in their orbit. The combination of the electrostatic force and their tangential velocity keeps them in orbit. Now, when the electron does fall into the nucleus, that process is known as electron capture. You can actually look it up. And when that happens, the chemical identity of the substance actually changes. The element changes from one element to another. And so the electron sometimes can fall into the nucleus, and other times, if it gains a lot of energy, it could fly away from the atom, turning into an ion. And an ion is basically a particle with unequal numbers of electrons and protons. But these things are not the norm. For the most part, an atom is electrically neutral under standard conditions, and electrons tend to maintain in their orbits. So they don't always just leave just like that. Now here's another question for you. If opposite charges attract, then that means that like charges must repel each other. So if we put two protons next to each other, they should feel a force that will accelerate them away from each other. Inside a nucleus, you have two protons that are very, very close to each other. So therefore, the electrostatic force has a tendency to pull them apart. So what keeps the nucleus together? What keeps the protons so close to each other when we know that like charges, they repel? And it turns out there's another type of force within the nucleus of an atom. It's known as the strong nuclear force. It's very powerful, much stronger than electrostatic force. And it keeps the nucleus together. It prevents the protons from flying apart. And as you've seen, nuclear reactions are far more powerful than chemical reactions. The strong nuclear force, it's a lot stronger than electrostatic force. Number 3, which particle has the greatest amount of mass? The mass of a proton is 1.6726 times 10 to the negative 27 kilograms. It's very, very small. And the mass of a neutron is 1.6749 times 10 to the minus 27. So a neutron is slightly heavier than a proton. Now the mass of an electron is a lot smaller. It's 9.11 times 10 to the minus 31. Now you might be wondering, what do these numbers mean? In terms of atomic mass units, a proton is approximately 1 atomic mass unit. The same is true for a neutron. Now a neutron is slightly more heavier than a proton, but in terms of atomic mass units, these two are very close to each other, and they're approximately 1. The electron is a lot lighter than the proton or the neutron, and it's about 0.000549 atomic mass units. So the atomic mass of an element is based on the number of protons and neutrons. Because the electron is so light relative to a neutron and a proton, the mass of the electrons within an atom is considered to be negligible. So the particle with the greatest amount of mass in this problem is the neutron. It's slightly more heavier than a proton. Number 4. What is the net charge of an ion with 12 protons and 9 electrons? To calculate the net charge, it's simply equal to the sum of the charges of the protons and the electrons. Just keep in mind, a proton bears a positive charge and an electron bears a negative charge. So we have 12 protons, each with a charge of plus 1. So it's going to be plus 12, since there are 12 protons. And we have 9 electrons, so it's going to be plus negative 9. Therefore, the net charge of this ion is going to be positive 3. It has a positive charge because there's more protons than electrons. If it has more electrons, it would have a negative charge. And so the answer for this one is E. Number 5. Which of the following is not true regarding atoms and ions? So let's look at A. Atoms are electrically neutral. Is that true? It turns out it is. So here's an example, aluminum 27. Aluminum has an atomic number of 13 and a mass number of 27. In a periodic table, you might see it like this. It might have a 13 on top and a 26.98 on the bottom, which I'm going to round to 27. The larger of the two numbers is always the mass number. The smaller one is the atomic number. Now, the number of protons is always equal to the atomic number, which is 13. The number of neutrons is the difference between the mass number and the atomic number. So 27 minus 13 is 14. The number of electrons is equal to the atomic number, which is 13 minus the charge. So there's no charge in this case. So it's 13 minus 0, so there are 13 electrons. Now, an atom is electrically neutral because it has an equal number of protons and electrons. So A is a true statement, which means C is also true. Now, an ion would look something like this. You would literally see a net charge. Aluminum has a positive 3 charge. So the number of protons is still 13, the neutrons is the same, but the electrons is going to be the atomic number minus the charge. So 13 minus 3 is 10. So ions rather, have unequal number of protons and electrons. So D is a true statement. And ions do carry a positive or negative charge, as we see here. Atoms don't carry a charge, they're neutral. A positively charged ion is known as a cation. So this is a cation. A negatively charged ion, like the fluoride ion, is an anion. Now the last statement has to be false by default. Ions have equal numbers of protons and neutrons. That's not always true. Some ions may have that, but the majority of ions have different numbers of protons and neutrons. So E is the answer. It's the false statement that we're looking for.